The strategy pattern is a design pattern that lets you define multiple ways of doing something. Instead of writing lots of if else condition, you move each behavior into its own class and plug it when needed. Let's try this out with an example. We will build a notification system that can send a message via email, SMS without using strategy pattern. We'll try this on a Java project. Let's create a package context and we'll have a class inside it as notification service. Since the requirement is to send notification, let's create a method send with type and message a string. Then since we have WhatsApp, SMS and email types, we'll do this on an if else statement. So for SMS, we'll give a system out.println just some message, and similarly for email, system dot out dot println message, and we'll also have another one. We'll say it as WhatsApp. Uh, Now let's go to our main method and we'll create an object service for the notification service class. Then we will call the send method. We'll provide a type and message OTP since it's SMS type. Similarly, we'll try for email as well. Email and then some message, and let's try to run this. Great, we got the output OTP and hello. Fine, the code works fine, totally fine, no issues. It's very simple one. Now assume we are getting some more requirements, some enhancements. Let's say we need a retry in SMS. Okay, let's add that. Yeah, so we have this retry method as well. Yeah, now also the code is going to work absolutely fine. But what if we are getting some more requirements like email must be HTML format, SMS must be plain text, WhatsApp must support media. The if else statement is just going to grow bigger and bigger. Testing is painful because we have to test all the paths because we are modifying the class itself. The logic is tightly coupled. One refactor and we need to test the everything. Okay, so this is generally violating object oriented principles like open closed principle and single responsibility principle. So to tackle this, we will use strategy pattern. So let's see how strategy pattern is trying to solve this issue. Step 1, let's create a new package called strategy. Inside this, we'll create an interface called notification strategy. And let's create an abstract method, send notifications, which is going to accept messages of type string. So in the meantime, I also created two classes, email notification and SMS notifications. Now let's create a new service. We'll call it as new notification service, which is going to use our strategy pattern. So here let's create a variable of type notification strategy as strategy. Then followed with that, we will also create a constructor. Then after this, We also need a method to send notifications. We'll call it as send notifications. Okay, let's run our code. We'll create new objects for the new notification service. One for the email service as new notification services, and yeah, we'll say email service dot send notifications, and we'll provide some message. Next, the same will try for SMS notification as well. Okay, so here we are creating two new objects for two strategies. We can also improve this area as well. Okay, let's see that later. What is the message for send notification? Okay, it's only messages. What we had earlier. Okay, only message. Fine. Just let's just add some message as OTP 1234. Great. Now let's run this, and yeah, as you can see, we're getting the output. Okay, this is working as expected. What we needed. Okay, let's try to improvise this furthermore. Instead of creating new objects for every notifications, we'll try to create something dynamic one like a set strategy. Okay. Hmm. So we'll create a method called set strategy, and this is going to get again the same strategy of type notification strategy. Okay, done. Now in the main method, instead of creating a new objects for every notifications, we can try something of this sort. Okay, let's rename this as service. Uh, service dot set strategy, and we can now pass SMS strategy. I mean, though we have email notifications in line number 15, we are overriding with SMS notifications in line number 16. Now if you can see, it's hello SMS. Okay, let's try to understand how the code is actually flowing. Let me add debug points in our project, and we'll start the debug now. So we have entered our main method. Now if I resume it, I go to the notification strategy. Right now the strategy is null, but inside the constructor the object has come, and again I'm resuming it. So now I'm again back to the notification strategy, and now we are inside the send notifications method, and when I click on resume again, we go to the notification strategy interface, and then we come back to the send notifications, and yeah, the output has come. Okay, let's have a walkthrough on how this design pattern has been written. Okay, uh, the first entry point is the notification strategy, which is an interface. So since our requirement is only to send a notification, we have a send notification method only, that's all. Later on, whichever method implements this, they're going to provide their own implementation. For example, the email notification is implementing notification strategy, so it is providing an implementation for the send notification method. Similar way, the SMS notification also does the same job, since the common functionality is to send only notification. Okay. Along with this, we have one extra method is the retry, which is independent only for the SMS notification. Now moving on to the context, it is new notification service context. So what do I mean by a context? So this class is the context of the strategy pattern, means I mean, notice how it doesn't contain any email or SMS logic. Instead, it receives the notification strategy through the constructor. That means the behavior can change without modifying the class. I hope you're getting the point. When send notification is called, it simply delegates the work to the strategy, making the design flexible, testable, and aligned with solid principles. Earlier, in earlier design, we had lot of if else. Then one class was doing everything. It was having a high coupling. Risky changes were involved, hard to test. But now polymorphism is used, single responsibility principle is followed, things are loosely coupled. We have feasibility to extend things, which is safe extensions, and strategies can be designed independently. You don't have to test everything now. The next question is, where can I apply this? So me as a SDET who generally works with automation, I see a suitable places where we generally use web drivers to call browsers. In a normal framework, if you go and see, uh, calling Chrome browser or Edge browser or Firefox will be within an if else condition. Maybe over there, this can be used. You can do it in a better way. Yeah, so that's pretty much about the strategy pattern. This is my first video. If you feel any comments, or I mean, if you feel any feedback, please tell me in the comments. I'll improvise in my upcoming videos. Thank you.